solve systems of equations algebraically. We're going to use substitution today. So substitution is when we have a value and we can put it into an equation and then solve for what's missing. It's something we've done always, but the big twist here is we've got to make a leap to understand that when we look at equations like this and this, what have we solved for here? We've solved for y. We have a solution there for y. This says y is 2x plus 7. This also says y is 4x plus minus 91. But what that means is that we can take the solution for one of those, let's say this one here, we could take this solution and substitute, get the idea, substitute that in for y. And then solve the equation like this to say 2x plus 7 equals 4x minus 91. We would solve that down to something that says x equals a value. Now once we have that nice value that we came up with there, we're going to take that, bring that right back up, and put it into that and solve for y. That's how substitution will work. In this, we're not using graphing, we're strictly using algebra to find the value of the intersection for these two. Here's our first example. I've got y equals 3x and y equals x minus 6. So I'm going to pick one of the solutions for y and substitute them in for the other solution. And that is, I'm going to take this 3x here and I'm going to put it in for that. So that's going to now read 3x equals x minus 6. So if we go back to our equations with a single variable on both sides, I don't have division going on here. I need to get this term over here. I want to get this down to one variable first. So I'm not going to divide by x. That's exactly what I don't want to do. Okay? What I want to do is, this is a 1x, so I'm just going to take 1x away from that side. And if I take 1x away from that side, I have to take 1x away from this side to make sure the equation stays balanced. Otherwise it's going to be tilted. So 3x's take away 1x leaves me 2x equals negative 6. That's what I'm left with. Now I'm dividing by 2 because I want this to be 1x. And 2 times negative 3 gives me negative 6. So now I have half of my answer. So I'm going to write down here this little dealio, my ordered pair. I know that x is negative 3. Now I need to take that negative 3 and I need to put it back into one of these two equations. I'm going to choose the second one here and say that y is equal to 3 times negative 3. So what I did was I took the value for x, which is negative 3, put it in for x, and now I'm going to solve for y here and say that y is equal to negative 9. I'm going to put that in that spot right there. Now I have a solution. This is my single solution. But I'm going to check it too. And I'm going to check it with the other equation to make sure that it's right. If I check it with the other equation, I got negative 9 as y is equal to, this equation here, is equal to negative 3 minus 6. Negative 9 is equal to, if I have negative 3 and I combine that with negative 6, that gives me 9 negatives. And that checks, which means that solution is correct. All right, let's look at one that is a little more complicated, but still within the realm of us being able to do this. We're looking for that single solution, that ordered pair. So this is going to wrap up with an ordered pair, something, comma something. And what we have here is we have a slope-intercept equation and we have a standard form equation. One of those equations has a solution in it, and it is the slope-intercept form. So we know that y is equal to 3x plus 8. So we're going to just take that 3x plus 8 and substitute it in for y. So that's going to give me 8x plus, now, that coefficient of 4 matters. That this is telling us in this equation, this is 4 times y. So we need 4 times the solution of y. So it's got to be 4 times 3x plus 8 equals 12. Now let's distribute first. We've got 8x plus 12x plus 32 equals 12. Let's get us down to one variable. One variable is a little bit more wieldy for us. We've got 20x plus 32 equals 12. Let's subtract 32 from both sides. That gives us 20x equals negative 20. And then x is equal to negative 1. So now I have half my solution. All right, let's take that solution and plug it back into one of our equations and solve for y. I'm going to use this one here. So that's going to give me 8 times negative 1 plus 4y equals 12. 8 times negative 1 is negative 8 plus 4y equals 12. I'm going to add 8 to both sides. That's going to give me 4y equals 20. Y then equals 5. We have a solution. Now let's check it. This is the beauty of this work. Every single problem we can figure out if we are right or wrong. I solved this one using this equation, which means I'm going to test it in that equation. In that equation I have, let's substitute y equals 3x plus 8. Let's substitute in for y. 5 equals, let's substitute in for x. 3 minus 3 times negative 1 plus 8. Can you see it? I can see it. 5 equals negative 3 plus 8. 5 equals 5. That checks. Great. When we're doing these like this, the way that we'll see solutions is this. Some of the things will come up saying that we have a value equals a value. So what might happen is we may end, and this goes back to that equations in a single variable on both sides. If we end up with something that says 7 equals 7, what we know then is that we have many solutions. If we end up with something with like 1 equals 7, then we have no solution. That means we have parallel lines. This would indicate that we have the same line, just two different versions of it. This would tell us that there's no solution, which means we have parallel lines and they will never intersect.